Okay, guys, this is my last lesson. I hope that y'all ready. I hope you understood everything I taught. We'll see next year. All right, so we are dividing complex numbers, and these are my examples. We're going to simplify, and you're going to answer in A plus BI form and reduce all fractions. This will help you with IXL Algebra 2 H5. So it starts you off real simple. We have 10i over 3i. If I just needed to simplify this, I could just cross out the i's, and I would be left with 10/3. Easy peasy. All right, number 2, A2, same thing. I could just cross out the i's, but if I cross out the i's, I don't have anything in the numerator, and that can't be, so there's always an imaginary times 1 here, right? So this will be -1/2. All right, that was example A. Example B, I have 1 over 3i. So the deal here is you cannot have an I in the denominator. That's not appropriate. You cannot have an I in the denominator. So to get rid of an I, we can simply multiply by an I, because remember, our I squared is the number -1. So if I multiply both the denominator and the numerator by I, what I'll have up top is 1 times I, or just I, and on the bottom 3i times I will give me 3i squared. Let's call this 1i, 3i squared. All right, I know that I squared is equal to the number -1. We just talked about that, right? So what I have up top is 1i, and what I have on the bottom is 3 times -1. And 3 times -1 is -3. So my answer is just I over -3. Or, again, you could have that 1i over -3. You can write it like this. You can write it just I over -3. You can write it as 1 over -3 and put the I off to the side. Any of these are correct. Any of these forms. All right, number 2. Same thing, I'll just multiply by an I. So if I multiply by an I, the top will become a 3i, and in the denominator I have a -4i squared. I know that I squared is -1, so this is really 3i times -4, we don't need that right now, times -1. All right, so 3 i's in the numerator, and my denominator is actually a +4. And that's it. That's fine. As soon as I get the i's off of the denominator, out of the denominator, and simplify, then I am done with that problem. Okay? So that was example A and example B. And real quick, I'm going to do an example C for you before I move on to the next video. All the directions are the same for this. We're just simplifying, and we're going to answer in our A plus BI form. And if I have any fractions, I'm going to reduce them. Okay, so my example C1, I have a -4 plus 5i over 3i. And C2, I will have a 1 minus I times, or I'm sorry, divided by -2i. Okay, so same thing here. All I really need is to get rid of the i's in the denominator, so I can multiply both the numerator and denominator by I. So whatever I do to the bottom, I must do to the top. Now, the numerator is a binomial. It has 2 parts, so I must make sure that I send the I to both of them. So I times -4 is -4i, and I times 5i will be a 5i squared. In the denominator, 3i times I will be a 3i squared. Okay? We know that I squared is really the number -1, right? So if it's really a -1, then this down here is actually a -3. We agree? The denominator. Up top, the I squared, again, that's really a -1. And if you haven't noticed by now, all the I squared does is change the sign of its coefficient. So this is 5 times negative 1, which is really a negative 5. Okay, so I need to write this in a plus bi form. A was my constant, just the real part of our complex number. And then your bi would be your imaginary part. So what I'm saying is I need to rearrange this. The real part has to come first. So negative 5 would need to come first, and then the minus 4i. Right, the part with the I has to come second. If there are 2 parts, the part with the I has to come second. Now the denominator was negative 3. And they said write it in a plus bi form, meaning it should look like it's separate. Like you get a negative 3 and you get a negative 3, like Oprah. So they were both divided by negative 3. Which means if I reduce this, these double negatives will make it a positive 5/3. And a double negative here would make it a plus 4/3. And I can write my I off to the side. My A is 5/3, my B is 4/3, and then I have my I. That is my A plus bi form. Okay? C2, I'm going to do the same thing. We'll start off the same way. I'll just give each, the numerator and the denominator, an I. Same scenario, I'm going to have to distribute in the numerator. So I times 1 is I, and I times negative I is negative I squared. On the bottom I have negative 2I squared. I squared is actually negative 1. So since this is actually a negative 1, that means that this whole thing is really a negative, I'm sorry, not a negative. Negative 2 times negative 1 would make it a positive 2 in my denominator. My numerator, again, since I squared is negative 1, I squared just changes the number of its coefficient. This coefficient would have been a negative 1. So if I have negative 1 times negative 1, that's really going to be a positive 1. Okay. So if I want to rearrange it and put the real part first, I have my 1, my positive 1, and then I have a positive I. So 1 plus I. And they'll each get their own denominator, which is the number 2. You get a 2, you get a 2. You can leave it just like that. Or if you wanted to, you could write 1/2 plus, and you could treat that like another 1/2 and put the I off to the side. Either way is acceptable. All right.